for protecting the environment and economy from invasive plants. So as we integrate landscape-level strategies into our invasive plant management, things like early detection and rapid response, we also need to be heads up about considering other landscape-level forces, especially climate change. Regardless of what we're trying to do with our stewardship, climate change is going to play a role in our success. And at the same time, we, through our work, can play a strong role in the success of diverse species in adapting to a changing climate. So to orient ourselves, the Sierra Nevada range is roughly outlined here on a map of California. Because of elevation, the region has been relatively less impacted by invasive plants than other parts of California. But California in general is a very invaded place, probably third only behind Hawaii and Florida in the U.S. Because we have such a wide diversity of habitat types, climatic zones, and a lot of species find it very pleasant here. Given the magnitude also of people and goods moving in and out of the state and around the state, there's abundant opportunity for introductions. We have lots of diligent prevention and early detection programs, but not nearly enough to keep up with the potential inflow of invasives. So the Sierra is, although it's been relatively protected by its elevation and harsh climate, we're finding more and more weeds at higher elevations, like this bull thistle in Yosemite National Park at almost 10,000 feet elevation. And so there's a lot of concern that we protect these places that are fairly remote but are bisected by roads and recreation and cattle and other things to make sure that they don't get overrun by weeds. So meadows are a particular focus for protection in the Sierra for several reasons. One, they provide important wildlife habitat. And two, they store snowmelt for slow release over dry summer months. They're so important, in fact, that the National Fish and Wildlife Foundation has a specific grant program dedicated to funding work to protect the hydrology, especially of Sierra meadows. And as an aside, we are starting a project with NIFWIP to rank various Sierra meadows in terms of their vulnerability to damage by invasive plants. We'll talk about that type of approach in a bit as one of the things that we can do to set good priorities. But we are already working with partners in the region to protect meadows with some obvious early steps to protect meadows that are obviously important and where people are already doing work and can use help to continue the good work that's being done there. So I'll talk in more detail later about some of the connections between invasive plant management and climate adaptation and talk about some of our recommendations for how to make that connection. But three general top-level connections I want to say right up front. And the first one is that simply managing invasive plants is in itself supporting climate adaptation. I mean, obviously you have to be doing your invasive plant management well. It has to be effective. But the various plans, including the National Fish, Wildlife, and Plants Climate Adaptation Strategy published several years ago by a whole consortium of agencies and groups, says that it's critical that we take immediate action to reduce existing ecological stressors. And invasive species are called out as one of the top ecological stressors. So just by virtue of doing good weed management, we are supporting climate adaptation. Secondly, deciding where you're going to work is a way to make sure that you are supporting climate adaptation. The places we prioritize for protection, perhaps specific topographic features that provide diverse microhabitats. Maybe these are important places for species to have the opportunity to find niches that continue to suit them despite a changing climate. And then third and last in this overview is that we can take specific information about climatic shifts and translate it to what does that mean on the ground for invasive plants. One of the things it means is that the potential places that those plants might grow could expand or contract depending on how favorable they find the changes in climatic suitability. So this is a screenshot. Elizabeth will talk more about our modeling and Cal Weed Mapper, an online tool. But this is a screenshot showing both current range in green and then additional range by mid-century in red. So with that, I'd like to turn it over to our senior scientist, Elizabeth Brisati. I will return later to talk more about ways that we can incorporate climate change into our planning, but Elizabeth's going to talk about the overview of the project in the Sierra and the modeling of climatic suitability.
Thanks, Doug. So our Sierra Nevada Meadows project was funded by the Wildlife Conservation Society. And as Doug mentioned, meadows are important both as wildlife habitat and for water storage. They are biological hotspots for birds and amphibians, including the federally endangered willow flycatcher, the endangered great gray owl, the Yosemite toad, and 9 species of trout and salmon. During the summer, meadows are actually considered the single most important habitat in the Sierra Nevada for birds. They're important because they provide shade and water during our annual summer drought, which lasts for several months. And as you probably know, California has been in a severe drought for several years. And models based on future climate predict that the snowpack is going to be decreasing in the Sierra quite significantly by the end of the century. And that's going to cause reduced spring and summer stream flows, which will increase the stress on wildlife in meadows, as well as reducing water going to urban water or agricultural water. So meadows are also vulnerable to invasion by weeds. Right now they have relatively few invasive plants due to the constraints of being at high elevation, which restricts which plants can grow there. However, with the warming climate, it's expected that invasive plants could increase, and already some species have been seen moving into areas that were previously thought unsuitable and too high elevation. The Sierra as a region is also experiencing heavy population growth, and it's very popular for recreation, so that increases the risk of spreading weeds from roads and from recreation, such as hiking or equestrian. So for this project, we worked at 17 meadow sites in 5 counties in the Central Sierra region. The elevation of the sites range from 2,400 feet to 7,800 feet. The ownership included California Department of Fish and Wildlife, the U.S. Forest Service, Pacific Gas and Electric Company, and private entities. And we chose the sites in large part based on which ones were shovel ready. In other words, where we had known partners who were already working there, who already had permission to access the sites and already knew what invasive plants were present and already had things like environmental permitting in place so that we could get in full 2 seasons of field work. And so those partners included the county agriculture departments, the Forest Service, California Fish and Wildlife, and the Truckee River Watershed Council, which is a nonprofit organization. And we worked both in the meadows themselves and also in outlying areas where there were invasive weeds that could spread into the meadows. The plant species we chose were prioritized by impact, their distribution in or near meadows, the feasibility of control. Typically for our landscape strategy on other projects we've worked on, we focus mostly on species that have capacity for high ecological impacts, but that are not widely distributed in the region, and we aim for full eradication over the course of several years. For this project, we focus our efforts a little bit differently because we were focusing on this one particular habitat. So we chose species that were in the meadows or nearby where they posed a direct threat for moving into the meadows. And Canada thistle and diffuse snapweed picture here are 2 of the species we worked on. So this project was connected to a previous project we did looking at modeling suitable range for invasive plants throughout California. We did this project completed in 2012, and we modeled projected suitable range in 2050 for 79 invasive plants based on their current locations in California. And those results are available on our website, Cal Weed Mapper, which we can provide a link to later on. But this is an example of one of the species we modeled. So yellow star thistle, which is a very serious problem in California. It's very widespread in California, but not too widespread in the Sierra yet. So on this map, the green areas represent places that are projected to be suitable range. They were suitable range in 2010 and still considered suitable range in 2050. The red areas are additional areas projected to become suitable as of 2050, including higher areas in the Sierra Nevada. And there are a few spots in here of yellow, and those are areas where the projected suitable range is expected to contract. In other words, it will no longer be suitable by 2050. So we use 17 global climate models, and we use the program MaxEnt to do the modeling, and with variables based on temperature and precipitation. And so we incorporated this changing climate suitability at kind of larger landscape level, not for choosing specific sites, because our modeling is not precise enough for that. So for this project, it did not actually determine which species we worked on, but it did give us an indication of whether a certain species could be potentially expanding or contracting in the area, and that way we were able to relate our results to climate adaptation later on. So this chart shows 16 species that were included in this project, and the right-hand column shows whether the suitable range was increasing, decreasing, or not changing between 2010 and 2050. And increase or decrease means a change of more than 15% of the area in California. And so those with the three species with the arrows pointing up, Medusa head, yellow star thistle, and Maltese star thistle, are all severely invasive plants that cause a lot of ecological impacts, and they are expected to have increased suitable range within the Central Sierra by 2050. And obviously there's a lot of range depending on the individual characteristics of the species. So we do have some where they're not predicted to change their potential range very much in the Central Sierra, and a few species that are actually potentially going to have decreased range. However, at a particular site, they may still be continuing to survive and to spread. So it certainly doesn't mean that we can ignore the ones, even if they might be having decreased suitable range. Another factor that's worth mentioning, although we did not include it in our modeling, is the increased carbon dioxide that's happening as a result of climate change. This graph shows the pretty dramatic increase in carbon dioxide concentrations in the last couple of hundred years, and especially in the last half of the 20th century. And there has been some research out there that increased carbon dioxide benefits certain invasive plants, specifically Canada thistle, spotted knapweed, and yellow star thistle, all of which were included in our project and all of which have serious ecological impacts. The work by Ziska showed that these species tend to grow larger when they're exposed to more carbon dioxide, and this relates to invasive plant management because if they grow larger, they may also be more difficult to control. For instance, herbicide concentrations that are currently being used may no longer be effective. Another change from that climate change will make with invasive plant management is that the timing of management may have to change. Plants may start growing earlier, they may have a longer growing season, so the methods that we've been using recently may have to be adjusted in order to adapt to the new reality. So in general, when we are planning landscape level projects, our goal is to look at full eradication of particular species in particular sites. And this is obviously a long-term effort, could be 15 years or longer, much longer than any project grant lasts. Because land managers are always fighting the seed bank, which could last for a decade or 15 years or more. So that means land managers have to go back every year, sometimes repeated times in 1 year to get new seedlings that are popping up. They need to return to an area even after they've removed all the plants to account for new seeds coming up from the seed bank. And so in order to have this long-term plan, even though it's going to go beyond the length of a particular grant, we made sure that the project partners understood that we are working towards eradication, even though this particular project can't eradicate things in just a couple of years. So we asked our project partners to generate a long-term management plan for each site. to document who is going to have responsibility for doing the work when there is grant funding and where they think they might be able to have project budgets. And then we also asked each partner that worked on the ground to provide us with field reports at the end of the season, just kind of a short summary of the species they worked on and how many populations were removed and the amount of progress they've made. We also asked them to take photographs to document their progress and to mark the locations of each species, each population in CalFlora, which is an online database for California. CalFlora is a separate organization from us, but our CalWeedMapper website is connected to their website. So in this way, data entered into CalFlora goes onto our website and it's publicly available so people can see where these invasive plants are in the Sierra. And this particular project removed 87 populations of invasive plants. And now I'm going to turn it over to Ed King from the Placer County Agriculture Department. And he's one of the partners who actually did the work on the ground, and so he'll describe his work in Bear Valley.
Yes, thank you, Elizabeth. So for this project, we've been conducting invasive weed and survey control work in the Bear Valley meadow. This is a meadow that's located at 4,500 feet on the western slope of the Sierras. It's roughly midway between Sacramento and Lake Tahoe, and it's near the Immigrant Gap up in the mountains. The meadow is it's owned by Pacific Gas and Electric Company. It's part of one of their hydroelectric projects. Next slide, please. Thank you. There you go. The Bear River bisects the meadow running roughly east to west, and the area is a popular hiking, camping, and fishing area. Now, historically, the meadow for probably well over 100 years was grazed by livestock, and that practice was suspended sometime in the 1990s. As for wildlife, Bear Valley is part of a migration corridor for regional deer population. It provides suitable habitat for special status species like the mountain yellow frog and the willow flycatcher, which we saw a picture of a couple minutes ago. But our primary concern as the agriculture department and partners with CalIPSI is invasive weeds, of course, and in particular in Bear Valley, Scotch thistle. You can move to the next slide, please. Thank you. Scotch thistle in California is considered a Class A noxious weed. And as far as I know, there's only a few occurrences throughout the whole state. And here's a couple other looks at the meadow and the Bear River there on the left, meandering through the meadow. And on to the next slide again, please. So Scotch thistle, it's a biennial thistle. It can grow upwards of 12 feet tall. It's a prolific seed producer, and seeds can be viable for decades, which is maybe our ultimate challenge with this project. And again, to the next slide. This is a photo that was taken just outside the meadow, probably maybe going back 10 to 12, 15 years ago. And you can see just left unchecked how dramatic a Scotch thistle infestation can become. Now, this site we've worked at intensely for a number of years and have had very successful treatments there, and we've been preventing any new plants from going to seed. Now a Scotch thistle, because it reproduces only from seed and it's biennial, it can be fairly easily controlled mechanically, and in fact, almost all of our work on Scotch thistle in Bear Valley is simply with a shovel. And next slide. Here's a look map of all the sites we've worked on over the past year. And we've conducted surveys in the May-June time period, and then another pass through the meadow in August, and then finally one final sweep through in the September-October time frame, just to make sure we're getting absolutely everything. And as we've been looking for Scotch thistle, we've unfortunately found rush skeleton weed, some yellow star thistle, and Scotch broom in the meadow as well. Now these infestations, as you can see, are primarily located near where Highway 20 cuts through the meadow. And unfortunately, it's an absolute travesty. They blew this highway right through the middle of this beautiful meadow, and it serves as an avenue for introduction of invasive weeds. So, and again, that's what we're seeing, the skeleton weed and the star thistle come in. As for control, we've applied milestone VM to the skeleton weed in 2014 and 2015, and we've seen close to a 90% decrease in skeleton weed after our 2014 treatments. And then we first sprayed the star thistle in 2015, and we manually removed the Scotch broom. So we'll be going back here in the next few months and evaluating those treatments and carrying on further with the project. And I think we can move on to the next slide. There's a look at us doing our surveys through the meadow. Back to Scotch thistle. Scotch thistle, over the past couple years, we've seen the total net infested acreage drop from about 1/2 acre to almost 0. And at this point, we're entering a long-term monitoring phase to ensure that we catch every plant in an early stage and prevent absolutely anything from going to seed, because that's just an absolute dramatic setback, obviously. And there's a couple of last shots of a rosette there, probably in the May or June time period, and here's another look at us doing some manual control work. So in doing this work, we're hoping to aid Bear Valley and adapt to climate change stressors without contending with the additional burdens of invasive weeds. And as the drought has persisted here in California, as Elizabeth was mentioning earlier, I've seen star thistle, in particular yellow star thistle, infestations further up into the Sierras, and they're threatening these high-value sites like Bear Valley. So it's an ongoing challenge for us in conducting wildland weed control here in California.
Ed, sorry about the slide advance. Your slides have a mind of their own. I think they're on a timer. Okay. Okay. Well, thanks, Ed. Let's go to Joel Trumbo with the California Department of Fish and Wildlife.
Good afternoon, everybody. Nice to be on the call. So, in some ways, our project at Smith Neck Creek has some similarities to Ed's project. We are on the east side of the Sierra, in this case, where Ed's project was on the west side. So if anything, just kind of shooting broadly here, the east side is the drier side of the Sierra because of the rain shadow of the mountains. So climate change will make the continued warming and drying of an already dry spot will make weeds like musk thistle and Canada thistle, which are the species that we have there at Smith Neck, going to make them all the more competitive. So if you take a peek at the next slide, just some overview of what we do. We have kind of a grand task. Sometimes I feel like jealous of guys like Ed who have a smaller geographic area. Our department, we have more than 1 million acres in the state, and depending on how you count, more than 700 properties. And what we're trying to do on all those properties is, manage lands for their maximum habitat value. But there's a lot of stressors and competitors to that. Like a place like Smith Neck, we've got probably had cattle grazing. It's on a, it's not a real populated area, but it is near some communities, and it gets a lot of people use. So there's always the chance for new infestations to get started. But like any big agency, one of our greatest challenges, and this is going to sound like whining a tiny bit, is that we just have a lot of property and we only have so many resources. So it's difficult to get people on the ground sometimes, or to get resources out at the site to do the work. That's why contracts and agreements and cooperative efforts like the one that we've had with California Conservation Corps and CalEPSI, the grant through CalEPSI. That's super valuable to us as a strategy, that kind of cooperative effort. Let's take a peek at the next slide. So Smith Neck Creek, it's on the east side of the Sierra, north of Truckee, so north of Interstate 80, in an area called the Sierra Valley. It's kind of on the south end of the Sierra Valley, a lovely, very large valley. The wildlife area itself is broken up into a couple of discrete units. It's about 1,400 acres in total, very close to the town or the community of Loyalton in Sierra County. Now, it's a fairly typical east side Sierra sagebrush habitat, and the primary uses of that property, or primary focuses, migratory winter range for deer, for migratory deer. You also have resident deer there as well, and of course other wildlife. There are several creeks that run through the area, not just Smith Neck, so we do have quite a bit of riparian habitat. So it's pretty diverse, riparian habitat, meadow habitat, some kind of on the edge of the forest as well. So definitely something that's a high priority for us to protect. When it comes to things like climate change, that's going to shrink habitat for certain species. It's going to change the habitat, its location or its quality and quantity. So to maintain this property or any of our properties for their intended purposes, like in this case, deer habitat or other wildlife habitat, we need to maximize the value of that habitat. And invasive weeds like musk thistle in Canada, they really make that a challenge. Take a look at the next slide. So as I've mentioned, our primary weed species there are musk thistle and Canada thistle. And as Elizabeth and I think Doug had mentioned earlier, the Sierra is kind of, from a weed standpoint, a lot of places in the Sierra are relatively, still looking kind of good from a weeds perspective. They're not, the lands aren't quite as disturbed. They haven't had as long of a history with people. But we do, even in places that are, up in the mountains, we do have introduced species. So musk thistle in Canada. Found out about these infestations back around 2009, 2010, when the Forest Service just kind of casually mentioned to me that there was some musk thistle at the site. And so later on, in going up there to take a peek at it up close and personal, we found that there was actually quite a bit more musk thistle than we had pictured. And there was also Canada thistle we didn't know about. So they're in limited acreages, but they're right in the spots where they threaten really valuable dry and wet meadow habitats. Next slide. So what's been really valuable for us is our partnership with the California Conservation Corps. The Corps, with the contract that they had this last 2 years with CalEPSI, and then work they had done for us under contract previously at the same site, it gets us people on the ground to do the survey work and the spray work. So that's very valuable. Just have more people there. It's been a good cooperative effort, and I want to continue it. Go ahead. A nice shot of the crew there. They're all young folks. Many of them are urban. Not all of them, but many of them. So it's a good opportunity for them to get out and see nature and gain some appreciation for wild places. I make it a point myself to at least spend at least a day with the crew, training them about doing their safety training for the herbicides, and also making sure they know the target species and then also the non-target species that we want them to leave alone. Next slide. So as I mentioned earlier, back in 2010, after a report from the Forest Service that musk thistle was on our property, we went out and actually surveyed the site and found that we did have both musk thistle and Canada thistle at the site. The Canada thistle was a surprise. I went out to look for the musk and ended up finding Canada too. The musk thistle is in very there's localized hotspots. They're pretty easy to find when you walk around. Canada thistle, on the other hand, hides out quite a bit more. It's not in any, there's no one spot where there's a big identifiable infestation. There's just a lot of little hot spots, or particularly along trails or disturbed spots. I imagine we get some horse traffic in there too, from the community, and a lot of people on foot in there visiting the site. So you see that there's a lot of trails, and you find that Canada thistle primarily along the trails. So back in, starting in 2011, for the first couple years, we did some herbicide treatments, just our crews. First, just using Transline, and then we made the transition over to use Milestone and Telar together. So back in 2014, we started to our cooperative relationship with the Seas. So they started spraying in 2014, and then all the way up through last year. So we've had, with musk thistle, we've had some pretty good success in the areas where we had very large, dense infestations. Those infestations have been reduced in scope, in spatial scope. But here again, we're dealing with the seed bank. So for us right now, our goals are to keep plants from maturing and setting seed, and then just keep coming up there, once or twice a year to remove the rosettes or the young plants before they set seed. Canada thistle is a little bit more challenging, just primarily because it's very hard to find. It tends to be kind of a low-profile plant, a little easier hidden than the large musk thistle, and it's just not seeing as much success trying to find it and control it with herbicides. So I would say we have reduced but persistent populations of both of these species. Let's take a peek at the next slide. So our strategy, get on the ground and survey for the weeds, and make at least annual herbicide applications. We have removed some plants by shovel. We have also removed flower heads from musk thistle using clippers if we had some plants get away from us. A lot of times, though, what we find is when we clip those flower heads off or clip the plant down, it just produces a shorter stature plant with flowers, closer to the ground. So reducing the seed bank is going to take some time, and then just continue to look in areas that are not yet infested, particularly along the riparian areas and the meadow habitat areas. Next slide. Well, I think that's all I've got. Thanks.
Thank you, Joel. Very interesting to hear some of the results from both of your sites. I would like to close it out here with several slides going over some of the recommendations that we've put together. Now, these are actually in a guide that is published on our website, and we'll mention that again at the end. So if you're curious to see more detail on them, you can look there. But basically, we came up with I think 16 recommendations in 5 different areas for ways to connect invasive plant management with climate adaptation. And those fall into these 5 areas: prioritization, which has the most recommendations, climate change planning, project planning, prevention, and early detection. So starting with prioritization, setting strategy at the landscape level. I mentioned that earlier, and basically that means working at multiple scales. So you may focus on managing your own property, but you also want to coordinate with your county weed management area and maybe beyond at the regional level. So that means figuring out spatial strategy, where outlier populations are, where leading edge populations may be, And that requires having good spatial data, including absence data, which is one of the major things we aimed for with the Cal Weed Mapper system, is to know and document on a map where each species was not known to currently exist. Secondly, aiming for eradication. So Elizabeth, Ed, Joel all mentioned the long-term nature of these projects. So we have had some short-term grants to support on-the-ground work, but none of them are long enough to pay for the entire project of eradicating something over the long term. So that does take some careful planning and communication and goal setting, but we really think that is the cost-effective way to go to get the best conservation outcome from your conservation investment. So we typically look for opportunities for eradication where it's possible. And obviously tracking that over time so that you're making sure that you're not letting seed set each year is critical. Third, focusing on early eradication targets. And that really is a combination, or it follows from the two ideas above that. Eradication is key, and getting to things early. So an outlier population or a leading edge population, that's something where you're still early on the invasion curve, where something hasn't spread so widely that it's no longer really eradicable. So that's the main focus of our landscape level strategy at this point, is to look for populations of bad weeds that are still isolated in areas where they aren't widespread, and planning for eradication of those. Screening naturalized species for future risk. So if you're like us, you get reports of non-native plants out there that land managers see, and they aren't necessarily plants that have spread or caused a problem, but you kind of wonder. And so one of the things that we're working on here with a new screening criteria developed by UC Davis is to take several hundred species, in fact, that have been kind of stashed on a watch list for years, where people have seen them and wondered if they're going to get worse. And occasionally a plant from that watch list has shown itself to start to spread and graduated to our inventory of plants that are known to be a problem. But we want to figure out which of those 200 plants actually have the highest risk of becoming a problem in the future. And so by screening those through a set of criteria, we can determine which ones are the biggest concern for potential future spread. Maybe they're in a lag phase now. Ranking site vulnerability for key habitat types. I mentioned that we will be working with the National Fish and Wildlife Foundation to kind of rank the vulnerability of different meadows throughout the Sierra to determine which ones are most vulnerable to invasive plants coming in and harming conservation values. And that basically translates to management priorities. Which of these are the ones that make the most sense to go work on first? And finally, mapping suitable range for weed species. Now, this isn't something that every group necessarily has the capacity to do. We were fortunate to get a grant that helped us do that in the past for Cal Weed Mapper. But the tools, excuse me, the tools for doing that are getting much more accessible, and it really requires having decent information on where things are found currently now in your region, and then extrapolating based on that. So I would encourage land managers through their, ideally through your state invasive plant council, to look for opportunities to work with researchers, perhaps at universities or agencies, to do some modeling to figure out where the suitable range for particular weed species may shift in the future. Climate change planning, several things that we recommend. One is to determine the top climate changes projected for your area. More and more information is coming out based on the global circulation models that help you see what is likely to happen in your particular area. Then second, taking the scenario planning based on that and saying, well, the major change that's going to happen is we're getting less rain and we're going to have more fire. Then figuring out how those changes will affect the habitat and the species that you most care about, whether they're the ones you're working to protect and or the ones that you're working to control, the invasive species. And if you can determine that a particular species is going to be very affected by that change, then you may want to adjust your management plans accordingly. One of the things that we've recommended to land managers in California is evaluating which of the non-native plants in your landscape may actually have some value for providing replacement habitat if they are more able to adapt to future climate conditions than are the natives. And then lastly, using your community of expertise. This is definitely a topic, climate adaptation, that needs crowdsourcing. You need the experience of lots of land managers to say what they're seeing on the ground, to make their judgments as to how the projected changes in climate locally are liable to affect the habitats and species that you're managing. Project planning, there are a few things that came out. Well, one thing that came out in particular, and specifically regarding Sierra Meadows, since many of them are looked at as possible candidates for major hydrological restoration projects. Typically, if grazing has resulted, overgrazing has resulted in an incised channel and the meadow hydrology is thrown out of whack, there may be plans for a major earth-moving type restoration. And so certainly invasive plant management should be coordinated with that. Probably shouldn't happen, maybe it should happen beforehand to minimize spread, but it certainly needs to happen afterwards as well. And getting best management practices for that construction is important. And then documenting and monitoring. So this is important for ongoing projects, whether you're the one doing it next year and the year after that, and you want to remember what happened several years ago, or whether your successor is trying to determine what happened way back when you were managing an area. Especially given the uncertainty of climate change, this is even more important than ever. And lastly, prevention and early detection. Collaborating with road and utility maintenance workers. We pulled that out, as well as the next one, working with firefighters on staging areas for wildfire fighting. Those are key vectors for introduction, certainly into an area like the Sierra, but also potentially other areas. And so working with the people who maintain the vegetation in those areas to make sure they're as weed-free as possible is critical to minimizing those potential vectors. And then another vector of introduction can be hay or straw used either as forage or erosion control. So if you have livestock coming into your properties, you have equestrians coming into your properties, look at the availability of weed-free forage and your ability to enforce a prescription that all animals coming onto the property have been fed weed-free forage. And then when you're undertaking erosion control projects as well, making sure that you have weed-free straw. And then finally, for early detection, which we all know is important, something as simple as setting up routine surveillance can be very valuable. I think a lot of us depend on more passive early detection, what we see out there, but making sure that we're inspecting the high-risk sites. They could be trailheads, they could be facilities, buildings, making sure that those are getting inspected on a periodic, regular basis, and that the findings are recorded. That, I think, it's not the same as acres controlled of a weed, but if you can show that you hiked all the high vulnerability trails and checked them off as weed-free, that's an accomplishment as well. And then finally, as we all know, training on weed identification is super useful, both for professionals who may know how to recognize the common weeds, but may not know how to recognize those weeds that aren't yet common in the area, but that could be coming in from neighboring areas. So an early detection may depend on them being able to spot that particular color of purple or something. And then volunteers, of course, as well. The more citizen scientists we can get involved, the better. And definitely making sure that everybody knows where to report something that they find, and to have a good communication pathway set up so that early detections do result in rapid response. So that's a quick overview of the recommendations. None of it rocket science. They're all the kinds of things that that land managers are contemplating anyway. Presumably you're doing some and want to do more. So if we can keep aiming for being as strategic and effective as possible with our weed management, we'll be ready to flex with the demands of climate change. So moving forward on our Sierra work, we're thrilled to have a strong infrastructure with partners working collaboratively to protect the Sierra Nevada at a landscape level, and then to have this ever stronger approach to setting priorities and documenting, tracking the progress that'll help our habitats adapt to a changing climate. So as I mentioned, we have some guides on our website. We have two. One is particularly about invasive plants in Sierra Meadows. So our recommendations for protecting Sierra Meadows from invasive plants, and also some of the research that we were able to synthesize on the impacts of climate change to Sierra Meadows. And then a second report, which is what I just went over at a high level, how to incorporate climate change resilience or adaptation into invasive plant management. So some recommendations in there, complete with some citations of tools like the UC Davis screening tool that I mentioned. So you can find these by going to our website at cal-ipc.org. And that's the end of our formal presentation. I would like to thank the Wildlife Conservation Society, California Wildlife Conservation Board, NIFWIF, and the Forest Service, State and Private Forestry for invaluable support and funding in making this kind of work happen in the Sierra Nevada. So thanks very much for your attention. And if there are questions, Karen, I don't know if you've been monitoring the chat line.
I have.
But let us.
Yes, so there is one question here. If anyone else has questions, just type them into the question box. Rochelle Desser is asking if the slideshow is available for downloading. And the webinar itself is being recorded, and it will be posted on the National Invasive Species Plant Council's website.
Excellent, and that's the case with all of the webinars this week, right?
Yes.
Great. I caught yesterday's, but I missed Monday's. I'd like to watch that.
And Eva Frost says, very interesting. Thank you all.
Thank you, Eva.
Any other questions? Okay, well, I think that's all. Thank you so much to everyone for attending, and thank you to our presenters and panelists for this wonderful presentation. I will be converting this to video, and it will be uploaded definitely by the end of the week, but very possibly by tomorrow will be uploaded onto the National IPSI website.
Wonderful. Thank you, Karen, and thank you, everybody, for attending today.
Jill and Rochelle also say thank you. Bye, everyone. We'll end it now.
Thanks. Take care.